All right. So let's talk about rational and irrational numbers. Now, when we're talking about these, let's start with rational numbers. Or let me start with irrational numbers. Now I can't go to irrational minus rational, isn't it? So when we are talking about numbers generally, numbers, the biggest set of numbers that we have is real numbers. Okay, real, not really real numbers. This is not the biggest. So the biggest set of numbers that we have is complex numbers. Okay. Now, real numbers are going to be a subset of complex numbers. They are a subset. They are just inside complex numbers. Now, in real numbers, all numbers that you think about are real numbers, except square root of a negative number, 0/0, a number over 0. These numbers don't exist, so these are not real numbers. All the other numbers that you think about are real numbers. Now, real numbers also can be split. There are a lot. We are going to have whole numbers. Okay. In whole numbers, you are going to have a lot of other numbers also. Whole numbers, these are the numbers like from negative numbers to positive numbers. In whole numbers, you are going to have integers. Integers, you are going to see we use the symbol Z like that. Now, integers are negative and positive numbers, including zero, but you shouldn't include fractions which are improper fractions and decimals. For example, 2 is a rational, is an integer, negative 3, 5, 7, but anything with a point, 1.2 is not an integer. 3/2 is not an integer. 0 is an integer. So all numbers which are proper counting numbers, negative or positive, without a point and then without a fraction, those are integers. We also have natural numbers. Now, natural numbers are basically integers, but you remove negative numbers and a zero. Okay, so natural numbers, you remove negative numbers and a zero. Now, the way I've even written this is even not true. So supposed to have integers here. And then in integers, that's where we're going to have the whole numbers. Okay. Inside whole numbers, that is where we're going to find natural numbers. Because whole numbers is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But natural numbers just remove the 0. In the same integers, you're also going to have prime numbers. Prime numbers, numbers that can only be divided by 1 and itself. For example, a 5. 5 can only be divided by 1 and itself. A 3. Okay, a 2. And numbers like 7. In the same integers and these others, okay, real numbers can also be even numbers or odd numbers. Odd numbers, these are the numbers 1, 3, 5, 7. Even numbers, these are the 2, 4, 6, 8 numbers. Okay, so you can actually also use a set to describe these numbers. The universal set of all numbers is a set of complex numbers. It's the biggest set that we have. It's the biggest set of numbers that we have. So you can have a set like this. So this is going to be complex numbers. Inside complex numbers, we are going to have real numbers. Inside real numbers, we are going to have other numbers like natural numbers, integers, okay, those guys. Inside real numbers also are going to have rational numbers and irrational numbers. But look at the way I've written these. If this one is rational, this one is irrational. I've written them separate, meaning that rational numbers and irrational numbers are disjoint sets. There is no number which is both rational and irrational. That is why inside the set of real numbers, these two sets do not intersect, because there is no number that does that to be rational and irrational. Are we good? Okay. So starting with rational numbers. A rational number 1 can be defined as a number, any number that can be written in the form a over b. In other words, any number that can be written as a fraction is a rational number. Okay, any number that can be written as a fraction is a rational number. So by definition, 2 is a rational number because you can write it as 2 over 1. Okay, 3 is a rational number because it can be written as 3 over 1. Okay, also 4 over 6. All these are rational numbers. Other rational numbers include terminating decimals. Terminating decimal. For example, 2.5 is a terminating, it's a decimal that ends. 3.75 is a decimal that ends. So it's rational. Also, non-terminating decimals, but they are repeating. Non-terminating, repeating decimal. For example, 1.2222222, but you can't end, so you put dots like that. But most you will not write this in mathematics. What you see is we're going to write 1.2, we'll write a bar on top. It means that 2 is repeating. Or for example, 1.323232. We will not write like that. We just write 1.32. The numbers which are repeating, will write a dash on top of them. So let's say we have got 2.5, 678, 678, 678. So this one, we can also write it as a 2.5 and then write 678. Now the dash only start at 6 and end at 8 because they're the only numbers that are repeating. 5 is not repeating. So these are rational numbers. Okay. Are we good? Okay. So you should be able to show that a number is rational. You should be able to show that a number is rational. Now, what does it mean if they say show that a number is rational? They are just meaning that write it as a fraction. Let's say, for example, they say show that 2.5, 2.75 is a fraction. What do you do? Just say let x be equal to the number that you've been given, 2.75. What do you do next? Just make sure that the decimal point goes at the end. So this will be our equation 1. How can I take the decimal point at the end? Okay. Multiply equation 1 by 100. So it will be 10 times 100, that is going to be 100x. 2.75 by 100, that is going to be 275. The next thing, just divide it through by 100. So this will leave you as x being equal to 275 over 100. I've written it as a fraction, but I need to reduce it to the simplest form. So look for a number that can go to the into the number that is on top and down without leaving a remainder. I believe a 5 can go. So be dividing until you reach to the simplest. Okay, to the simplest. So this one was terminating, so you see where we ended. But for a number like 1.2 with a dash on top, this one is non-terminating. How do you show it as a rational number or expressed in forms of a fraction? So what you do is the same. Let x be equal to 1.2. The first thing you want is the decimal in front of the number that is repeating. For this one, yes, it is. So that step we are going to leave it. The next step is take the decimal behind the number that is repeating. So we want to move the decimal once. So by what number am I going to multiply with? Very good. So multiply equation 1 by 10. So it becomes 10x is equal to 12. The point comes here, but because 2 is repeating, just write it again. Put again a dash on top. Okay. The next thing is now when the decimal is in front of the number repeating and behind the number repeating, now subtract the two equations. Okay, subtract the two equations. I'll write first the big one. 10x is equal to 12.2 with a dash on top, and then x is equal to 1.2 with a dash on top. 10x minus x is 9x. 12 minus 1. I'll not talk about the 2 here because it's cancelling. It's the same number. If I subtract, like, it just cancels. So it just be 12 minus 1. That is 11. So I'll divide through by 9, meaning that x will be 11 over 9. Meaning 1.2222222 is the same as 11 over 9. If you have a calculator, you can confirm. Punch on your calculator 11 over 9. You see the answer that it will give you. Okay, so we have written that, and you can see this is the simplest form. There's no number that can go into 11 and 9 without leaving a remainder except from 1. Are we good? Yes. No, for this one, when it's repeating, you don't go direct to do that. So what you do is you subtract. Okay, you only divide direct if there is no repeating, like it's a terminating decimal. Let me use another example so that you just get this match. Let's say I've been given 3.75. There is a dash on top. You want to express it as a fraction. So first thing is, let x be equal to 3.75. So be equation 1. But because the decimal is not in front of the number that is repeating, the next step will be take the decimal in front of the number that is repeating. So by what number am I going to multiply the equation 1? By what number? I want the decimal to come here. Are we able to see that? By 10. Okay, good. So x times 10, that will be 10x, and that will be equal to 37.5. Don't forget to put a dash on top. Now that the decimal is in front of the number that is repeating, the next thing is now take the decimal behind the number that is repeating. So multiply this equation, multiply equation 2 by also 10, so that the decimal goes behind. So 10x times 10, 100x. 37.5 by 10, 375. Just write a point and write the 5 once. Okay. Now, at this point, this is where you subtract. Now, you always subtract the equation where the decimal is in front of the repeating number and behind the repeating number. So what you do is subtract 3 minus 2. Okay, so that will be 1000x is equal to 375.5 repeating, then 10x is equal to 37.5 repeating. 100x minus 10, it is going to be 90x. This 5 and this 5 will cancel. 375 minus 37, that's what we want to subtract. Remove a 1 here, it becomes a 15. 15 minus 7 is that 8. Here it remains as a 6. Should be a 3, should be a 3. So it is a 3, 3, 8. This point divide both sides by 90. So it will be 338 over 90. So you need to check if there's any number that can go into both without leaving any remainder. Let's say 2 into 3 on top, that will be 1, remainder 1. 2 into 13 is a 6, remainder 1. 2 into 18 is a 9, so that is 169. 2 into 90 is a 45. So you can try to punch this on the calculator. Is there anyone with a calculator they punch this, they tell me the answer? No one has? Okay. So basically that is how I go about it. Is this okay? Are we good? How are you behind? So what we did is we got the 100x, we subtracted the 10x, it gave us a 90x. Then now we subtracted 375 and 37. I'm not including the point 0.5 because it's the same. 337 minus 37, that is what gave us this number. Then we wanted to remain with x, so we divided both sides by 90. Does that make sense? What did you get? Okay, so good. Okay, let me give you one more example. One more example. Let's say we've been given negative 1.652. We want to write this in a fraction in the form a over b. Now, when you are writing in the form a over b, meaning as a fraction, the denominator can't be equal to 0. B should never be equal to 0. Remember what we said, if b is equal to 0, that is a complex number. It's not a real number. Okay? Doesn't exist, in other words. So let x be equal to negative 1.652. This will be equation 1. For equation 2, what we are going to do is multiply equation 1. We are going to multiply equation 1 by what number so that the decimal point goes in front of the repeating number? By 10. Good. So it becomes 10x is equal to negative 16.52. From here, you want the decimal to be behind the repeat number 1, 2. Okay. So by what number am I going to multiply equation 2? Good. By 100. So multiply 2 by 100. So we're going to get 10 1000x is equal to negative 1652 point, just write the number which is repeating again, 52. This will be equation 3. You always subtract the equations where the decimal is in front and behind the repeat number. So subtract equation 3 minus equation 2. That is 1000x is equal to negative 1652.52, and then we have got 10x is equal to negative 16.52. So if you subtract 1000 minus 10 is 990x. Now here, If they are negative, this is where people can get confused. You're always getting what is on top minus what's down. So here it's negative 1652 minus negative 16. I'm not even writing the 5.52 because you know these guys will cancel out. Okay, so never get confused there. You end up writing something else. So this is the same as just a positive 16 minus 1652, and that will give us a negative 1636. At this point, divide both sides by 990. When you divide both sides by 990, just try it. If this was a final exam, this question was 5 marks. At this point, they'll give you 4 marks if it is not reduced fully. So now that will be your struggle. For me, I would advise if you reach here and then you know that for you just to reduce it, it will take you some bit of time. First, go and answer other things, and then when you have finished, or maybe if you have failed everything, now come and start wasting time here. So you can put a 2 in the number in on top and down, you get like a negative 818 over 495. You get your other one mark. So that is how you would go about it.